today's JFocus here at A1. Give a warm welcoming applause to Melissa McKay from JFrog.
Thank you, everybody. So glad to see all of you here. For many of you, it's your first day, the end of your first day at JFocus, and it has been a pleasure for me to be here so far. How many of you, is this your first time here at JFocus? Wow, wow, that's like half of you in the audience. That's pretty awesome. Can I just get a round of applause for the organizers of this conference and how well it has been put together so far? This is going to be a pretty lighthearted talk. It's a good one for the end of your day and get you set up for celebrations later. And I promise that I won't actually be talking about skinning any cats during this session. I'm not that type of a person. But what we'll talk about instead is how you can tangle yourself up into some bad practices sometimes when you're writing your Docker files. And before I go any further, I was instructed not to wear this hat. And because of the lighting, and I just am so excited that I even have lighting to worry about at a talk right now, because I've been so used to virtual talks and being on Zoom all the time. So this is great. So I got a little rebellious, and I'm wearing the hat. But since this talk is all about doing things a little bit differently, I will wear my hat a little differently so you can see my face. All right, this is my first time in Stockholm, actually. My first time physically here. My name is Melissa McKay. I work for JFrog. I've been with JFrog now for 2 years, and I became a Java champion at JFocus, my first virtual attendance of JFocus. That was pretty exciting. And I also became a Docker captain during that time period. So I get to spend a lot of time with the other Docker captains and find out about what's coming, down the pipe, what's coming up next for Docker and containers in general. This is my contact information. Twitter is probably the best way to reach out to me if you have any questions or anything like that. You could also follow me on LinkedIn. Prior to being a developer advocate, I always find this important to say because it makes a difference. I was a developer. I was a developer for 20 years, all the way from a lowly intern to a principal engineer at a pretty huge company. And during that time, I just found a real passion for speaking. I had an opportunity to go to an unconference, which is a very different type of conference. If you've ever heard of them or ever get the opportunity to go to an unconference, take that chance. It was probably one of the best decisions I made in my life. I did do it on my own dime because at the time, I was not paid to travel to these kinds of things. So it was very, very small. It's not the type of conference where you have someone standing up front talking to you the whole time. Instead, you have discussions with everyone in a group. So everyone gets to participate and talk about whatever subject is near and dear to their heart. I met a lot of passionate people that way, got involved with other developer advocates, and that's how I became a speaker today. So if any of you are interested in doing that in your career, it can happen. It works. All right, how many of you got new pets in the last 2 years? Anyone? Yeah, there's a few of you. The rest of you just aren't being honest. You've done something in the past 2 years. I'm actually a cat owner. These are my 2 friends. I rescued actually my children rescued them as feral kittens last summer when we were all stuck at home and we're getting a little lonely. I call them our pandemic pets, our COVID kitties. And again, this is not a presentation about skinning cats. Obviously, as you can see, these 2 are alive and well. Instead, I will include a bunch of cute cat pictures for you to enjoy, because who doesn't like that? And anyone already familiar with my image and container talks that I've given already, I refuse to use any graphic of shipping containers in my slides. It's never going to happen. That's my commitment. And if you're the first to report to me any marketing or anything around a session of mine that has a shipping container picture in it, please reach out to me on Twitter, let me know. I will give you some kind of prize for that. In addition to cute cat pictures, I'll be going over some of my early experiences with Docker, and specifically the Dockerfile, and how that development went for me. We'll see if any of you can feel the same pain that I went through, or you'll learn something today so that you do not feel that pain. How many of you are using containers right now? Just about everyone. How many of you are using them in production right now? Okay, little less, but about the same. It's pretty amazing now. Even just a couple years ago, I could ask that question, and there just weren't that many positive responses. It's very clear how much containers and the use of containers has grown. There's a lot of different reasons for that. Some of it is just the tool sets around it has exploded and just made it a lot easier for developers to get involved and start jumping in and wrapping their applications in containers. Now, we all know it's not a solution for everything, but it definitely is something that makes our lives a little bit easier when we don't have to worry about what environment we're actually running in. We can just, wrap it up, throw it out into the cloud, and it runs. It's pretty nice. So let's start with the Dockerfile. That's where I started. You pretty much have all the building blocks that you need to get your application out the door and into production. There's all of these commands available to you. This is a pretty fairly exhaustive list, but with these, you can pretty much do anything your heart desires. You can do all the right things, and you can do all the wrong things and everything in between. They're pretty much building blocks. You can put things together, and it's pretty amazing what I've seen come out of some of the projects that I've worked on. If you want to know, obviously a lot of you are using containers already, and maybe not just Docker containers specifically, but containers in general. There is some references that you can go out and learn about that. When I started, it was not as common. Several years ago, I started using Docker containers, and it was pretty tough for me to start. I was on a brand new team and did not even know where to start. So that was quite the experience. So today, we're going to go through 10 things. I just gathered 10 concepts that I wanted to share. And we'll talk about the do-nots involved with that, and of course the related do's. These are things I learned through trial and error when I first started with Docker. Some you may be aware of these pitfalls already, but my hope is you'll find one or two or more of these helpful, and think about making some edits to your existing Docker files you might have in the wild right now. So several years ago, I was brought onto a project that was initially developed by a third-party contractor. And it was time the company decided to bring that project in-house and to build a team around it so that now my team would be responsible for maintaining that project and making sure that we got new features developed and stuff. It was a very small team to begin with. And the first thing I realized was, yes, it was wrapped in a container, and there was a Dockerfile in the source. That was the first thing that I looked at. And pulling up this Dockerfile, I just read the readmes that were available on how to get the project up and running and get started, and that's how we started. And chaos went from there. Several things I learned through this journey. The first was ignoring the Docker ignore file. I did that immediately. Didn't even know it existed. Didn't know that was there or what the use would be. So of course I didn't use it. And one of the things that annoyed me the most was how long it took to build my images. And this project was a pretty big. It turned into a pretty big space. So every time we would build and anytime anything would change, it just took forever to build on my machine. And that was just because I didn't fully understand how the Docker context worked. Why would you use Docker ignore? This is kind of a contrived example here, but it includes the exact problematic line that we had in our Dockerfile to begin with. And you can see it right there, that third line down, copy with 2 dots. And if you don't realize this, this is copying and delivering everything in your current working directory to the daemon and then into the image. Things that you might not want to put in there. One reason to use the Docker ignore is to prevent such a scenario. You don't want to send everything to the Docker daemon. You, first of all, immediately invalidate your cache for a lot of things, so you don't get to save that time. And you may be sending test files or other resources that are not needed in the production image. You may be sending user-specific files. Maybe you have your own environment set a certain way, and so you've edited some files. Or secrets, even. You may be sending secrets across. The Docker ignore file works very much the same way as git ignore, and it just prevents you from putting in extra stuff into your image that you don't need. So let's be very clear about what this is doing. When you run a docker build command to build an image using this particular Docker file that I showed you, everything in that current directory is sent to the Docker context. Everything is then copied into the image. Avoiding adding any tests or specific files or secrets that you've stored locally is important. And at first, I thought that when I started learning this, I thought I could just improve my build time by explicitly copying only what I wanted. But under the covers, still, everything gets sent and shipped to the Docker daemon, even if you don't end up using it in your image. In this case, this particular Docker file, you wouldn't. There's just 2 files there being copied. So my project continued to take forever because I was still shipping all of that stuff. And this just showed what it looked like. I was happy with my 2 files that I ended up in my quite a bit smaller image, which was nice. But that wasn't going to work for me. So here's our first do and do not. Don't ignore the Docker ignore file. Here's an example of some of the items that you might want to put in there. Of course, your readmes, your passwords, if you have any of those. And one thing interesting is that Git directory. I had been sending my Git directory this entire time and putting it into my image with that explicit copy. So that was something that I fixed once I learned about Docker ignore. All right, number 2, using untrusted base images. And I'm going to confess, when I first started ramping up in Docker, the first thing I did, I just followed those README instructions. I got everything up and running, and I was happy with it. I didn't want to touch it. It was working. It was fine. I wanted to bury myself in the code that I was familiar with, which was Java. And there was some JavaScript in there. And surprisingly, there was a Python component, too. That was kind of a fun project. But I didn't realize then how images actually worked until later, when our build broke with an error message that said, sorry, your base image doesn't exist. I didn't know what that meant. So I went digging around. It turns out that the base image that was in our Dockerfile was actually getting pulled from a private repo of the original third-party contractor, which had been out of the picture for over a year. So good luck trying to get that base image. It was gone. We had to make our own, so we had to learn very fast how base images work and how to put one together ourselves for our project. A problematic base image probably isn't going to be as obvious as this one, named evil image. But my point here is to pay attention where your base images are coming from. This is becoming more and more important every day, especially with our supply chain issues that we hear about more commonly now in the media and everything. Pay attention where they are coming from. They are dependencies like anything else. They really should be pulled into a dependency management system of some kind, like Artifactory, or managed along with the other binaries wherever you have them stored, everything that you rely on for your build. There are official images that come from Docker Hub. These images, Docker has a dedicated team that is responsible for reviewing and publishing those images and that content. That team works in collaboration with the upstream software maintainers, and security experts, and the greater Docker community as well. So you're a little bit safer if you're pulling from official images from Docker Hub, but just realize that you're still relying on a third party. So I would suggest to bring anything that you rely on into a private registry of some kind so that you can track it, make sure it's not changing out from under you, make sure it doesn't disappear like what happened to my team. You can also, it'll help you avoid malicious packages. You can get the latest updates, that kind of stuff. So here's an example, the second do and do not. Make sure that you're pulling from a registry that you recognize, and preferably one that you have control over. Also, understand, by default, everything comes from Docker Hub, unless you explicitly say or tag an image that it should come from your registry. So understand that, and also understand that just because it's listed as the from, there's an inheritance there. That base image could be based on another image, which could be based on another image. It is worthwhile to do your research and figure out exactly where those are coming from and what is inside. Makes sense. We should know this about our applications. So I got a little scared because I didn't even know really where to look for a base image that was going to work for us. I had to do a lot of homework, tear some things apart, figure out what was relying on what. So how do we make this decision? What do we use, especially as Java programmers? What on earth, do we just go out to Docker Hub and search for Java? Is that how we're coming up with our images? Do we just go Google and get the first example that says, from OpenJDK? Is that the right thing to do? There's also this whole other nomenclature. If you're not real familiar with Linux, these are actually Linux distributions, and when you see names like Buster and Bullseye, those are different Linux distributions. For Java specifically, you would recognize JRE and the JDK. So you might decide, well, if I want a smaller image, if I want less in my production image, I would choose a JRE over a JDK. You could certainly, just limit, based on your Java version. But once you start learning these other names as well, you'll see them in other projects, not just Java projects. There's no mystery here when you realize what those names indicate, and I just listed them here for you. If you need to install additional packages on top of any of these images, you might need to pay attention to the Linux version at this point. And just to note, the Alpine version is interesting. Alpine is very popular. It's considered to be small, one of the smallest. It produces small enough images that are really especially for container use. However, just realize it does use a slimmer C library that's different than what Debian uses, which we're more used to. glibc, or the new C library, the Alpine uses actually it's called Muscle, and it requires an OpenJDK port. And in fact, if you were to look at the documentation for the official OpenJDK image, it says that the port for Alpine is not even in a supported release by OpenJDK. And according to their documentation, Alpine images are only released for early access OpenJDK versions, and they are not updated after GA. So I would consider maybe looking for something different than the official OpenJDK Alpine image. And it makes sense if you're already paying for support for a specific distribution from Azul, perhaps, or from IBM. It makes sense to stick with their official images. And I do know they have Alpine versions that are maintained and supported. All right, moving on to number 3, not defining versions. This particular outcome is gorgeous in a cat, not so gorgeous in a project. When you have incompatible versions flowing in and you don't have control over all of those variations and variables. And this one kicked us, as you would expect, Our build just started randomly breaking one day, and there was a lot of troubleshooting involved trying to figure out what changed. One way to solve that is make sure that your artifact management has a way to identify for you every single component of your project to make sure that it is actually the same. That is one way to manage this a little bit better than we did. We unfortunately had everything in the same repo. It made it really difficult for us to track things specifically. But one of the things that I didn't realize was not just versions of, our application, but the OS packages too. And in fact, this was what happened to us. We ended up building a new image. No caching was involved, so everything new came in, and there was an incompatibility there. It took a while to figure out exactly what package that was. Once we did, we learned we needed to make sure to specify the version that we were interested in using. You should always, always have a bill of materials for your build. This is more important now than ever. Know what versions of everything is installed. Artifactory has a metadata called build info, which is super helpful with this. You can eliminate, multiple moving parts and control your version updates a little better this way. So the do's and do nots here, again, a contrived example, but the do not section. Notice the tag latest. We started using that. We thought that was great. We're getting the latest and greatest. What I didn't realize at that point was just how tags actually work for Docker images. They are not always going to be stable, and latest might not actually be pointing to latest today or tomorrow. It changes out from under you. So really important to understand what you're getting. Latest may not even be a stable version, depending on where you're pulling these from. Also, caching. It was really interesting when we started adding new members to our team, and they would build these fresh images, and they didn't have the benefit of all of the image cache on their machine, and things just did not work the same, which makes sense, right? Just like in Java, if you were to, remove your entire Maven, local Maven repository, you might have some issues. That happens pretty frequently when a new programmer comes on board and they've got to build everything fresh. And all of a sudden you realize, oh no, we have this dependency that we relied on that none of us realized was just coming from our local cache. Same goes for images. That can happen to you too. All right, number 4, never updating. This is a mess, and I know a lot of us are guilty of this. We've been on teams where keeping our software updated is not as much of a priority as getting the next release out or getting the next new feature out. That has always been a push and pull with different parts of companies. Some are organized differently than others, and it's just a more difficult process to really iron out. It's really easy to fall into that idea of if it's not broken, don't fix it. And that really means that there are bigger problems going on. But there does really need to be a balance there. Updates need to be scheduled. They need to be regularly addressed. Just waiting for your build to break before doing those updates is never a good idea, not a good strategy. And why? There are 3 reasons I put here. Security updates are important. And again, security updates are important. On number 3, security updates are really, really important. Block out time every development cycle to spend on this kind of maintenance. Some believe that defining versions or not defining the versions, for example, using latest, is a good way to get the latest security updates. But I'd argue that depending on the size of your project, that increases the number of changing variables during your build, and you might end up with some difficult troubleshooting there. I like to control your variables. I'm kind of a controlling person that way, I guess, but I think it's important to do, and I think it's just quicker to decide today we are going to upgrade this version rather than randomly do it out from under you. This particular file, notice not only the base image needed to be updated, it's old, but there's also packages that were being added on top of the base image. So every time this image was built fresh, it would be building with a package that had known vulnerabilities in it. Something to consider and make sure you have a process to deal with that. So how to fix it? Obviously, decide the version that you want, get it upgraded, make sure you're going through all of your testing cycles. I would do these kinds of upgrades by themselves during a maintenance session rather than have everything else come in at the same time, new features and bug fixes and all of that. Reserve some time for this specifically. All right, we're almost halfway through. 5, including your build tools. I see this all the time. I see this everywhere in examples online. When you're out looking for just how to build a Dockerfile, it's really easy to come across examples that look like this. And they come from some base image that includes all of the tools that you need to actually build your project. And this isn't, again, not restricted to Java. This is for anything out there. They're all supported base images that just make it easy for you to get your project up and running. It works, but you end up with an image that's much larger than it needs to be. You don't need all of that extra stuff in a production image. Why would you be putting Maven libraries in a production image? Also, it's just best to minimize your attack surface from a security perspective. The less that you have wandering around in your image, it just goes to reason that the less you have to worry about potential security vulnerabilities. You might ask, why not just copy over the artifact from a previous step in the process rather than include the whole building of the project within the image build? And one argument that I've heard for that is that some teams like to be able to include the specifics of how the project is built in the Dockerfile. They kind of keep it as a record of how it's built. And that makes it more buildable by anyone, regardless of availability of tool sets in a local environment. So that might be another reason you would want to include Maven in there so that someone doesn't have to install, the correct version or whatever on their machines. The solution to this, I suppose, is really just going to depend on how your team is organized. For example, there was a period of time when I was on a team that we just weren't involved in containerization of our project. We just focused on the libraries and building the libraries. We passed those off, and it was more of an operations chore to put that together and then actually deploy into containers. So just depends on what works for your team, how you're organized. But one thing to consider is multi-stage builds. That way you can get the best of both worlds. You can get a smaller image without those build tools in the end. And here's an example of what that might look like. So in the do section, there's 2 from statements. That whole first part is the build of the project. And then when you hit the second one, that is actually all that is going to be included in your image. This is something you should really focus on doing. Only include the pieces and parts you absolutely need for your application to run in production. All right, number 6, using external resources. This is another one I see all the time, and it's pretty blatant out there. I see a lot of curl statements and Dockerfiles. I see a lot of, wget, things where you need to connect to some external resource to get your artifact that you need or dependency that you need. One example that we had in our project was there was a proprietary piece of software that we needed to install in the container. And part of that process was just to curl out and get it. But we were just getting a script. we were just pulling in a script, and that script was running. We just, ran it. You wouldn't do that on your own machine, would you? That's something that I would be very careful about. I mean, the first thing I would do if I was presented with a script like that is go get it and look at it, see what it's doing, right? Before just running it on my machine. I mean, that's the classic going to Stack Overflow and getting instructions to delete your hard drive and just doing it. So at the very least, make sure you know what you're getting. And consider pulling it into your own binary management system, like Artifactory. This way you can also not only pay attention to what it's doing, but you can also control when it gets updated. You will notice when it gets updated, and then you can update it at your own pace and not at the whim of the script owner or the maintainer. In our case, this was noticed especially when the maintainer of the script just basically moved it. So we were curling out to something and not getting anything back, and we had to contact the maintainer of the project and get all of that fixed. And that's when it occurred to me this probably wasn't the best relationship to have. So the do and do nots here, this is just an example of pulling that script in, owning it, making sure you are in charge of those updates, you are in charge of what is actually happening with that script, when it is running, that kind of stuff. Trust but verify. Again and again and again, we take for granted this stuff that we pull in. There are so many binaries out there now, a bunch of open source projects. We are all in this position where none of us really want to reinvent the wheel. We want to use what's already there so that we can build bigger and better things. And I get that, totally understand that, but a lot of times we're being a little bit careless about what we're pulling into our projects. And it might not even be a problem with a vulnerability, so to speak. It could be just a licensing issue that could come up and bite your company later. So if you aren't aware of what your developers are pulling in, what they're using in the project, restricting that in some way, or maybe not restricting is the right word, but monitoring it, you can definitely count on that coming to bite you at some point. All right, 7. This one's pretty obvious. Hard coding secrets. Not so obvious as hard coding config. This is something that we struggled with because we really didn't have a good pipeline at the time. That was something we were building from scratch for this particular project, and learning how to do that with a container and where to put that in our build pipeline and stuff. This is an example of something I saw in a Dockerfile. And see if you can figure out what is happening here and maybe what the intent was here. If we just go through it step by step, you see that there's a base image. Okay. Then we're doing some updates. We're doing some upgrades of OS packages. All right. And from what we've learned already, we might be concerned about updates that we don't want right now. So that would be something to take a look at. But look at that third line. What is going on there? And this isn't exactly the Dockerfile, but it is certainly modeled on one that we came across on our team. What happened here is someone responsible for building the base image, added some secrets they shouldn't have. But instead of rebuilding the base image and providing a new version, they thought it was sufficient enough that during the build cycle to just remove that file. Just remove the parts that they didn't want to be there. When you start learning more about how layering works with Docker images, this is not a good solution. Maybe what you're looking at the end, if you were to exec into the container, for example, built from an image like this, you wouldn't see that file, but it's still there. It's still there on the system in an underlying layer. So always best to rebuild this image. Now, I'm sure there was some good reason why this base image wasn't rebuilt, but I think just understanding that this particular fix wasn't really a fix was more important to us at the time. As far as config and hard coding config, the port that's exposed here, that was something that mattered to us when we started adding other environments and we had some restrictions on port requirements, things like that. Going through our testing phases and our integration tests and going through QA, finally getting into a production environment, sometimes that port needed to change. It's much better to put that in. I'll go ahead and move to the do section. It's much better to expose that as an environment variable that you can pass in rather than hard code that. It's very future thinking, kind of future proofing your image development. In this case too, we absolutely required that the base image be rebuilt so that we weren't going through with that silly line of trying to remove secrets that would just exist in an underlying layer. All right, number 8, just doing too much. There's a point when you start, or you might start, especially in the beginning, thinking that your Dockerfile is just a glorified shell script, and it is not. It is meant to be a description of the blueprint that you're going to launch containers from. It's not supposed to be littered with a bunch of actions and processes that are really meant to be like a pipeline, a build pipeline or a test pipeline. This is an example of what I'm talking about. And again, this comes from not quite understanding what it means when Docker, creates layers and then caches from those layers. In this particular file, you can see once again, this was an interesting thing. We had a base image and they were trying to remove an old package for the purposes of installing a new package. That's another candidate for just rebuilding the base image. That's really what needed to happen there. But down at the bottom, can you figure out what the problem with that is? It looks like there is a script that does some cleanup of a database and then unit tests are run. This isn't, what happens when a test fails? And then you try to rebuild this image. And think again how caching works. Nothing has changed. If all you do is, let's say the test fails, you just fix the test. It's one of those cases. And you try to rebuild this image. Well, you've already gone all the way past that line cleanup database. And now you're going to try to run unit tests again. You're going to have some problems. And side effects are all around whether or not you're caching something that's unexpected. We had some crazy effects when we did stuff like this in our Dockerfiles. And of course, this file is contrived for simplicity, but it was again modeled off another file that I worked on. Most importantly, Dockerfile should contain idempotent operations only in order to provide repeatable builds. So the do's and don'ts of this, basically don't treat your Dockerfile like a shell script. It is not. Rather than running integration tests during the build of a Dockerfile, consider launching a container and running tests against the container in another environment meant for integration testing. That would be a much better approach, and keep your Dockerfile as simple as possible. Okay, we talked enough about caching, and I added this one, unnecessarily busting cache. So there are times when you do not want cache because you want to verify that the build from beginning to end is legit, that it's going to work in any scenario in any environment. But there are times when you do want to benefit from the cache, and the one that I can think of the most is a developer. If you're involved in repeatedly building images on your machine, it would be nice to be able to benefit from that cache. Just like being a Java developer, you can benefit from, if you're working with Maven, for example, be able to benefit from your local Maven repository. It's nice to not have to repeat all of the downloading of stuff that you already have. So an example of this, and we also had many instances of this, I see a lot of this when I see projects working with NPM. And trying to figure out how to utilize cache without downloading everything every time you run the build for an image. Performance really takes a hit. You want to minimize that time for images to be pulled or pushed across the wire. As layers are created, if any of those layers changes, that means that that layer has to be regenerated. Everything below it also needs to be regenerated. So take a look at this file. Very simple, named things so that it makes sense what's going on here. We have our base image. We're just copying from our work environment. We're copying a dynamic file in, meaning a file that changes a lot. Next, we're copying a static file that never changes. It's just some requirement for our application. And then last, we're sending in a script that we use to start our application. So the do and do not here, reorder those. Make sure that your dynamic files happen later in your Dockerfile, not earlier. That can take, sometimes you might find yourself in a catch-22. That might indicate you need to do some reorganization of your folder structure or something in your project. But in this case, it's pretty simple. Moving stuff that changes a lot lower. Now, as Java developers, you'll probably see this a lot if you were to use the Maven Docker plugin. You can see that class files and third-party libraries and stuff are actually separated from each other. And if you could see a Dockerfile, it would appear that the highest layers would include third-party libraries, things that aren't likely to change as often as your local, your class files that you put together and that are in active development. So that's one way to improve performance when you are building Java in containers, making sure that those dynamic files come in as late as possible. Okay, I'm leaving the best for last. I had the pleasure of meeting Thomas Andolph from TrueSec before his interview at the DevOps Speakeasy this morning. And I don't know, have you all found where that is? It's right where the massage is given. So surely you've all found where the massages are being given out. The DevOps Speakeasy is right next door to that. And we chatted a little bit this morning about what he was speaking about. His talk is tomorrow at 3:35 in room C3. It's called Quickie, the top list of securing your developer workstation. And as we chatted, he asked me if I could please help to lead the charge to get Docker to get rid of running as root. Processes inside a running container, they're just like any other process on the system, albeit a few constraints, but they should not be running as root in a container unless absolutely necessary. Doing that opens up the possibility of escaping the intended confines of those processes and someone unintended gaining access to host resources. Reduce that attack surface area by following the principle of least privilege and treat those processes like you would any other in your application. Monitor their use, make sure you have the appropriate user and group running those processes. You can create a user inside the Dockerfile. You can also determine a user when you launch a container. However, I like it being inside the Dockerfile so that you don't forget or you don't have to constantly look to see if it's there. That's the case for base images, because when you're pulling in base images, pay attention to whether they are bringing along with them the root user. Here's an example. And most of the examples I've shown you so far where there was nothing in there about creating a user and group and controlling any of those processes. And here we are again. my start script is just going to run as root. So I feel bad bringing that up sometimes, just because I feel like this is something that we talk about over and over and over again, and I feel like everyone should know about it. But on the next slide, you'll see a statistic that's pretty scary. But here's an example of how to do what I'm saying. This actually is just modeled after some examples I've seen with Spring Boot. They often, you'll see them create a new group and a new user and use that group and user for the rest of the build. Same with like Postgres. I've seen the Postgres container does that. A lot of the other containers will do this for you. Always good to check though. Find the source of those and make sure that that's what's going on. So there's a report that came out recently. This is the 2022 Cloud Native Security and Usage Report by Sysdig. Sysdig is a pretty popular monitoring company. This came out of 3 million containers that they were observing, and 76% of those were containers that were run as root. So even if everyone's heard about it and understands, maybe we're not taking this risk seriously enough. Hopefully this number will go down. But for now, this is something that I think maybe folks that are building containers just don't completely understand. I have a resource at the end that I'll share with you as well. It's dated now, actually. It's 2017, I think, but it's just a blog describing an example of how this can happen, how you can get yourself in trouble by not assigning a user and group. I love articles and blogs like that because I'd rather not just be told. I want to be told why. So like today when Matthias told me, don't wear your hat, he also told me the reason why is because no one will be able to see your face because of the lighting. So only then was I ready to take my hat off and do the right thing. So mind your do's and don'ts. That's all I have for you today. Remember that these 10 things are not an exhaustive list, but I think they're the most important. I hope all of those items will encourage you to be thoughtful when you write your own Dockerfiles. And also, I would not be a responsible Frogger if I didn't invite you to visit the JFrog booth. We're giving away a Star Wars Lego set, so you can either go to the booth to get this QR code, or you can take a picture of it now and sign up for that raffle. And then also visit the DevOps Speakeasy. We had some incredible interviews all day today, and we're going to be doing the same all day tomorrow. That space is open over there. You can sit and listen to the interviews. They will show up on Twitter, and eventually they will show up on the YouTube channel for the DevOps Speakeasy. These are resources that I just put together. Obviously, the Dockerfile documentation at Docker is the best. It has improved quite a bit over the last few years. Definitely point someone that direction if they're new to containers. I know not everyone is using Docker as their tool, but it is a very good starting place. Learning about official images, the place where you can find Docker Hub's official images. Let me give you a hint. It took me a while to figure out if I really wanted to break into a base image and figure out how it was made. I wasn't sure how to do that. There is a cool tool called Dive that you can use that will give you some indication of what's inside those images, other than launching a container and execing in and poking around, which could take a while. But if you Google Docker official images and you look for a GitHub link, that's where you start. You would navigate into that, find the project that you're interested in, and then be able to go hunt for it. They're all built the same way, which is good. They follow some good practices, so it's good to use them as a standard for how you might want to build yours as well. But there's always a maintenance link, and it's another GitHub project that you can go to, and that is where you will find the Dockerfile itself for those base images that you're curious about. Multi-stage builds, included a link there. There's the article about running as root that actually showed an example as well I was pretty impressed with. The SysTig report, if you're curious, there's a lot of good information in there about other statistics around images and containers running in production today. And then I wrote an article on dzone about storing your images, what you might consider when you're looking for an image registry, some place to put them. There's some good information there too. All right, thank you very much. This is great. Yeah. Are there any questions? I can't see you very well, but I can hear you if you shout them out. Pardon? Podman, yes. So yes, there are other solutions. If you're not, do you run, what's your development environment? Are you on Linux? Yes. So that's the advantage there. Windows and Mac, I don't think it's still very easy to run Podman or anything else to make that work. But Windows, though, with the WSL2, you could use Podman in there, right? You should be able to do that. That is another option. Anyone use the Maven plugins for Docker or anything like that? No one? Anyone use build packs? So something I discovered when I was playing around with using the Maven plugins, because the idea there was to obfuscate the whole thing. Why do we all need to worry about writing Dockerfiles and learning all this stuff when we already write Java and we know our application? That was one of the advantages of creating these plugins. But what I discovered was, first of all, the way the image is split up into layers might not always be the way you want it. It's something that you need to, again, trust but verify. Sometimes it's good, it turns out okay, sometimes it doesn't. And also, one thing I noticed, the particular plugin I was using actually ended up using Paketo build packs underneath. That's all fine and good, except that when I went to look at my image cache, there's other images that get pulled in that are not part of my application. And they're needed in order to run the build packs against your, to build your image. But what you might want to consider there is not relying on the defaults, and make sure that you're setting up the plugin to use your version of the build pack that you have collected and put in your own image management so that you can control it. All right. Anyone learn anything new? Awesome. That's the best part for me. As long as you go away with something valuable that you can take back to your team, that makes me happy. All right, everybody, have a great night. I don't know what you all have planned next, but I'm sure there's going to be some celebrations going on. And I'll see you all tomorrow.